something we should always think about in our data when we make our observations and we gather our quantitative data, in other words our numbers. We should always be careful with how accurate we think we are, because inbuilt in every experiment method will be some ways to make us get the wrong answer. So there's always going to be errors in my science, and unfortunately we have to live with that. But on the good side, we can always talk about it in our evaluations after our conclusions, and we can always figure out ways of showing that we understand this whole thing. And that's probably the important part out of this. So every measure, we've already talked about precision and accuracy, precision being how closely stacked our results are, if they're all linked or close to each other. And accuracy is actually how close we are to the given or real value. So every measurement we make really is only an estimate, because our measuring tools are often a little bit, shall we say, shoddy. They're not going to give us exactly what we want. And if we choose to measure with the wrong thing, it makes that error even bigger. So our accuracy goes out the window. So we've got to be very, very careful with that. Now, there are factors in our method, or the way we actually perform our activities. So if we're not very good at doing lab work, then we're going to find that our errors are going to be much, much greater, or they should be much, much greater, because we will make more mistakes than someone who is quite competent about their lab skills. And unfortunately, some of us don't bother learning too much about it. We don't try to compensate with that. So we need to think about these sort of things when we are going through our activity. Now, random errors are errors that are caused by us not collecting our data properly. A chief cause of this is something like not reading a scale properly. So if we've got a scale with lots of numbers missing, or there are lines, especially on what we call an analogue scale, which are things like a ruler or a wristwatch, not a digital wristwatch, a wristwatch which has got the old analogue scale on it, or maybe even a voltmeter, an ammeter, where we have to a little bit put our own interpretation on what we're seeing. This tends to make a random error. So we're not doing things properly, or even when we're measuring volume using a measuring cylinder. If we don't have our eyes level with it, things like this are part of our random errors. So that's why your teacher is always saying to you, repeat. How many times are you checking on your results? How many pieces of data are you gathering? If the more we actually gather, it actually helps us, because we actually get a lot better idea about what the real value is. So the more data we get and then use an average for, lets us decrease our random errors. Now, there is another type of error that does exist, and that's a systematic error. And that's things like to do with how we go about doing things. If we are using an appliance which has, even it can have digits, numbers that we can actually read straight off. But if we haven't calibrated it properly, in other words, we haven't zeroed it. When we are in year 7, we learnt about using a electronic balance, electronic scale correctly. So remember, one of the first things our teacher told us, we start off with, we turn it on, we see it is not reading 0.00 grams, so we hit the TARE or 0 button. And that is called calibrating. And so every time we use an electronic thing or a sensor, we should calibrate. Certain ones need calibration more often than others. And this is another source of error, and we would call that a systematic error.